Hi there, welcome to this video for AP Precalculus. We are going to solve some trigonometric equations, specifically trig equations that have a linear structure. You will go ahead and be successful if you know your sine and cosine values of the unit circle angles. Again, that's very, very important. Go back and check out the unit on the unit circle. If you know the left hand trick, really all you need is your left hand in order to easily have access to all those values. I'll kind of outline that here. You'll be successful if you can solve linear equations, and you can use trigonometric identities to rewrite a trigonometric function in terms of sine and cosine. These are the most important to understand, that your cosecant and secant are reciprocals of sine and cosine, and that we can go ahead and write tangent and cotangent in terms of sine over cosine, and cotangent is cosine over sine. Although I do like solving tangent and cotangent values with understanding values of the graph. For instance, if I have a tangent function like this, I know it's an increasing function. So if I have something like this, right, like tangent of pi over 6, that's going to give me the smaller square root of 3 value divided by 3 versus pi over 3, which is the bigger angle. That's going to give me the bigger value. Okay, but those are very important things to know how to do. So how do we solve a trig equation? Well, it's just like other equations. We are going to go ahead and do reverse order of operations. Undo addition, subtraction, undo any multiplication, division, and then we will undo the angle measure that corresponds to the specific trigonometric function value, okay? And we'll continue solving if needed. And so I'll kind of show you how that works. It's important to note, usually here we're solving for the angle value, and we're not necessarily finding a value, so it kind of works in reverse of how we did the unit circle. When solving for all solutions, so this is specific to equations that say find all solutions, it's important to note that sine and cosine are periodic, right? They're cyclical and they can keep going. And so if we have a problem that says solve for all values, we have to go ahead and add a 2 pi k to our answer, where k is an integer, because our period is 2 pi. These values will repeat over 2 pi. If it's tangent and cotangent, we only add pi k, because the period for tangent and cotangent is pi. Makes sense, right? Secant and cosecant, same as sine and cosine. It's going to be 2 pi, because they're the reciprocal functions of sine and cosine. So let's jump into an example. Here is example 1. The function m is given by m of x equals cosine of 2x plus 4. Find all input values in the domain of m that yield an output value of 9/2. So I'm going to go ahead and take my function. They want m of x to be equal to 9/2. And so m of x is cosine of 2x plus 4 equal to 9/2. So again, the first thing I'm going to do, I'm going to subtract 4 on both sides. Subtract 4 on both sides. And what we get is cosine of 2x is equal to 1/2. Again, I could subtract 8 over 2, right? 4 is 8 divided by 2. It gives me 1/2. Or you notice that 9/2 is 4.5, so I take away 4, that gives me 0.5. I like the 1/2 here because this is going to be important when solving this. Cosine of 2x equals 1/2. What this means is I have to go ahead and I have to say, where does cosine of what angle equals 1/2? This is essentially what I'm doing in my head. So I like to go ahead and again use my left hand, and I want my x values to be 1/2. So this is going to be pi third angles, okay? And I want my x value to be positive. So where is that? Well, that's going to occur up here, and the other quadrant is going to be down here. So this is pi thirds, and the other one is 5 pi thirds, right? Almost 2, almost double. Okay, so I can go ahead and solve this. So 2x is going to be equal to pi thirds, and we have 5 pi thirds. Now, because they said all values, I'm also going to add a 2 pi k here to both of these solutions, plus 2 pi k, because they'll keep going ahead and hitting these values. And now I have 2x. I just want 1x. So now I'm just going to divide both sides by by 2, divide by 2, divide by 2, divide by 2, divide by 2. And what we get here is we get our first solution, x is equal to pi 6 plus pi k. And for our second solution, we get x equals 5 pi 6, right? I'm just cutting the thirds in half, plus pi k, plus pi k. And so you also divide, if you have the divide here, you also divide that 2 pi k by those by that value as well. Okay, and before I go on to here, I want to say we have to identify what k is here. So we're going to say where k is an integer. K is an integer. And if you want to be kind of really bougie here, you can add in some upper division mathematical notation here. We can say k is an element of the set of integers, where you do this z. Again, how I kind of did that was I did the first half of z, and then the second half, looks like that. Okay, so that's the symbol for integers, the set of integers, whole numbers. Okay, all right, let's look at example number 2. And in example number 2, we're given a secant example. The function g is given by g of theta equals secant theta plus square root of 2. For what values of theta on the interval pi to 2 pi is g of theta equal to 0? So here's what they want us to solve. Where is g of theta equal to 0? And g of theta is secant theta plus the square root of 2. Plus the square root of 2. And we want to know, where does this equal 0? So we're going to go ahead and solve. What do? Well, subtract square root of 2 on both sides. Okay, so I have secant theta is equal to negative square root of 2. And I don't have values for secant. I need to use sine or cosine. So what is secant? Well, secant is the reciprocal of cosine. So I'm going to take the reciprocal of this side. That's cosine theta. And I'm going to take the reciprocal of this side. Negative 1 over square root of 2. And so here, I'm going to go ahead and rationalize this. And when I rationalize, you'll be like, oh, I recognize that value. Square root of 2 over square root of 2. And so what this gives us is, it gives us cosine of theta is equal to negative square root of 2 over 2. Hey, hopefully you recognize that, right? And so where does this happen? Well, this happens, and again, I can draw my little unit circle. It's going to happen over here and over here. So that's going to be 3 pi fourths, and it's going to be 5 pi fourths, okay? One back and one forward from pi. So do I keep both of these? Do I have to add 2 pi k? These are usually the questions that happen. We only add 2 pi k when it says find all solutions. And we don't do it specifically when they give us a domain. Notice how they say from pi to 2 pi. So they only want, their answers, they only want, guys, occur in the southern hemisphere of our unit circle. So guess what? This 3 pi fourths, throw it away, and our only answer here is 5 pi fourths. Pretty straightforward. Okay. All right. I have some practice problems for you. Go ahead. I want you to pause me, try this, and then I will talk through the solution here. Let f of x be 1 plus 3 cosecant x and g of x equal negative 5. In the xy plane, what are the x coordinates of the points of intersection of the graphs of f and g for 0 to 2 pi? Pause me, I'll show you the solutions. All right, before I go any further, I want to make sure you have the setup correctly, where they are essentially asking where is f equal to g. So you set your two functions equal, and you go ahead and solve this. Pause me, I'll show you the solution here. Okay, hopefully you went ahead and subtracted 1 on both sides, and then that would give you 3 cosecant x equals negative 6. From there, you go ahead and divide both sides by 3. And that gives you cosecant x equals negative 2. And then here's where I take a reciprocal. Reciprocal of cosecant is sine of x. And the reciprocal of negative 2 is negative 1/2. So where is sine of x equal to negative 1/2? Well, you want your y values, right? This is a y value to be equal to 1/2. And so if you're looking at your left hand, I can put down this finger, my pi 6 finger, and then my y values are 1/2, and we want them to be negative. So that's going to be quadrants 3 and quadrants 4. Now, do they want all solutions or do they only want a certain one of these? Well, they said here for the domain 0 to 2 pi. So we're going to take both of these answers. Answer should be 7 pi 6 and 11 pi 6. So hopefully you got that. Okay, practice problem number 2 here. Please pause me. I want you to solve this problem. It says the function d is given by d of x equals 2 sine of 2x. Find all input values in the domain of d that yield an output value of square root of 3. So go ahead, pause me, and I'll show you the solution to this one. Okay, here are the solutions. Do you want d of x to be equal to square root of 3? D of x is 2 sine of 2x, so we'll divide both sides by 2 to get sine of 2x is equal to square root of 3 over 2. Where your y values are equal to square root of 3 over 2 is at pi thirds, and so that's going to give you a quadrant 1 and quadrant 2. So you can see here, this is the solution for pi thirds in quadrant 1. Here's your solution in quadrant 2. And because they say all input values right here, all input values, we add the 2 pi k. So don't feel bad if you don't have that. On the AP exam, in fact, if you forget the 2 pi k, you still get 1 point if you find both angles, but you get the second point for adding all values. And then I have to solve, I have to divide both sides by 2. So I divide everything by 2. And so for our first solution, we get pi 6 plus pi k, where k is an integer. And then for our second one, if we divide everything by 2, that 2 cancels with that numerator. Or you get 2 pi 6, which is the same thing as pi thirds, plus pi k, Sorry, get rid of that 2 there, plus pi k, where k is an integer, okay? All right. One more practice before I give you another example here. So again, please pause me, try this one. The function g is given by g of theta equals 4 sine theta. For what value is the theta on the interval pi halves less than or equal to theta less than or equal to 3 pi halves is g of theta equal to 2. Pause me, I'll show you the solution. Okay, for this example, we set g equal to 2. We divide both sides by 4. And we get sine of theta is equal to 1/2. And then I need to know where is my y value 1/2. So again, that's going to be our pi 6 angle. And so for y values to be positive, it's in quadrant 1 and in quadrant 2. So we have pi 6 and 5 pi 6. Now, they only want answers in this interval, pi halves to 3 pi halves. So that is this part of our unit circle. So we get rid of that solution there. Okay, answer is just 5 pi 6. All right, hopefully you're feeling a little bit okay now. Let's go ahead and see what happens if I have an additive value on the inside. The function f is given by f of x equals cosine of x plus pi 6. Find all values at x for which f of x equals 1/2 on the interval 0 to 2 pi exclusive. So notice they include 0, they exclude 2 pi. So if I have an answer that falls at that value, you're going to use angle 0. Okay, so I have cosine of x plus pi 6 is equal to 1/2. So, okay, I don't have anything to undo. Where does cosine equal to 1/2? Where's my x value equal to 1/2? That is going to be equal to pi 6. Or sorry, pi thirds. This is equal to pi thirds, right? As well as in, it always helps if I draw a picture. I don't know why I just don't draw a picture all the time. Here, and for my x values, here. Okay, so that's going to be x plus pi 6. I take whatever's on the inside. So you notice this matches here, right? And these are going to be equal to these two angles, 5 pi thirds. And now I go ahead and solve, okay? So x is going to be equal to pi thirds minus pi 6. And then over here, x equals 5 pi thirds minus pi 6. It's probably doubtful that you would get an answer. They probably want you to go ahead and simplify here. So what does this give us? We get, what? 2 pi 6 minus pi 6, which is just equal to pi 6. That makes sense, because 60 degrees minus 30 degrees is 30 degrees. Okay, and then over here, we'll do the same thing. I'll go ahead and multiply by 2. We get 10 pi over 6 minus pi over 6. I just multiplied top and bottom by 2, if you're confused. All right, I'm finding a common denominator, and so we get 9 pi over 6, which reduces to 3 pi halves. 3 pi halves. Okay? Common denominators. I know you guys love the common denominators. Both of these, note, are in this interval, so we're keeping both of those solutions. All right. Okay. Next practice problem. Similar idea here. Go ahead, pause me. Try this one. I'll show you the solution. Okay, this one was pretty straightforward. I set my function g equal to -1. They want all solutions in the first revolution 0 to 2 pi exclusive. And so they say, where does sine equal to -1? That's going to be our south pole. That is right down here. So x minus pi fourths, the interior, is equal to 3 pi halves. And I can go ahead and add pi fourths over. You see that here. And really, for this one, it's not too hard. If I add pi fourths, I'm at 7 pi fourths. So if you kind of understand visually or conceptually what's going on, you don't have to find a common denominator. But again, what I did is I found a common denominator, multiplied top and bottom by 2, and added them together. Pretty straightforward. Okay, last example that I have for you here says let f of x equal sine of x minus square root of 2 and g of x equal negative sine of x. Oh my gosh, in the xy plane, what are the x coordinates of the points of intersection of f and g on this interval pi halves to 3 pi halves? So the first thing I'm going to do is I'm going to set up my problem here. I have sine of x minus the square root of 2, and this is equal to negative sine of x, right? F and g are equal, so I set the two functions equal. And now I'm going to go ahead and solve. And so what I'm going to do is I'm going to combine like terms. I have a sine of x on both sides. I'm going to add a sine of x on each side. And I know you're like, what the heck? What are you doing? Well, just pretend it's a variable. What if it was an x? Or what if it was a y? Something very, very basic like that. So now what we have is I have two. Sine of x plus sine of x is 2 of them. I have 2 sine x's. Minus square root of 2 is equal to 0. And now it's a lot less scary. So I did have to show you that where you have the same function on both sides. Now if they're a different power, we have a whole different strategy going on. Okay, but they're both linear trig functions, right? Sine to the power 1. So I move them together. Here we'll add a square root of 2 to both sides. Okay, so I get 2 sine of x is equal to the square root of 2. We'll divide by 2 on both sides. We get sine of x equals square root of 2 over 2. And hopefully you don't feel too scared about this one. This is the good old pi fourth angle in quadrant 1 and in quadrant 2, which is 3 pi fourths. But pay attention to your domain. They do not want quadrant 1. So I'm throwing away that answer. Answer 3 pi fourths. That's it. All right. Okay, same kind of idea with this practice one. Pause me, try this one, and then we'll show you the results. Oh man, this one was straightforward. I added cosine of x to both sides. Okay, so those cancel. I get 2 cosine x. Then we go ahead and we divide by 2 on both sides. We get cosine of x equals 1. And then where is your x value equal to 1? It is not pi. That is -1. Our answer is angle 0. Angle 0. Notice how they don't go to 2 pi. Usually if it is 2 pi, they exclude 2 pi. But your x value is at 1 at angle 0 here, okay? All right, that's going to do it for this lesson on solving linear trig functions. Put it in terms of sine and cosine. Use your unit circle to find those values. And if you have all angles, remember that we have this 2 pi k, where you say k is an integer, okay? All right, give this video a thumbs up. I'll see you in the next one.